Okay, in this next section, we will be solving trig equations, kind of getting away from those cumbersome trig identities a little bit. And this will be a little bit easier than establishing identities and stuff we were doing a minute ago. So we're still dealing with trig stuff, and we're solving equations here. And this time, we're actually wanting to find the angle x that makes this true. We're not verifying an identity. We are solving for x. So on a problem like number one, what I want to do, if possible, is to get my trig function all by itself. I want to get sine x alone. And to do that, I will add 1 to both sides of this equation. That will give me 2 sine x. Negative 1 plus 1 is 0, equals 0 plus 1 is 1. Then I would divide by 2. So I'm trying to solve for sine x, get sine x by itself. So sine x equals 1/2. You can cancel those. And at this point, we have sine x equals 1/2. If you are using a calculator, then you could punch in the inverse sine of 1/2 to solve for x. But you should be able to do this without a calculator. And we're going to do this problem simply by thinking about the unit circle. So let me pull in the unit circle so we can look at that. There we go. So what I want you to do is find all angles x from 0 to 2 pi, so all the way around the circle, where sine is equal to 1/2. Remember, sine is the y-coordinate, and my y-coordinate is 1/2 right here, and again right here. There, I didn't like that box around there. Okay, so sine equals 1/2, and I like to answer in radians. Notice it did say 0 to 2 pi, not 0 to 360. So our answers are going to be pi over 6 and 5 pi over 6. And that would be your answers for number one. Notice this is not an inverse sine question. I didn't write down inverse sine. Inverse sine you only answer on the right side of the circle, but for this problem I did specify give me all angles from 0 to 2 pi. So there are your answers for number one. Number two is a very similar problem, a little bit uglier. We're going to gradually step up ugliness on these problems. So for number two, notice I have two tangents in here. I want to group those two tangents together. This one is kind of by itself, and it really doesn't matter what you want to do. You could move this tangent over. And actually I think I may do that. I kind of like having my variable on the left side of the equation. So what I'm going to do is subtract a tangent x from both sides of the equation. 2 tangent minus a tangent would give you 1 tangent x minus the square root of 3 equals, now those cancel, tangent minus tangent is 0, so you do need to write equals 0, because nothing's on the right side of the equation now. I will add the square root of 3, add square root of 3, and I get tangent x is equal to 0 plus square root of 3, which is square root of 3. And tangent's a little bit of a pain because tangent is not explicitly written on your unit circle, so we have to kind of do some guess and check. First, I want tangent to be a positive answer, and if tangent is positive, then that means we have to answer either in the first quadrant, so I'm looking somewhere over here, because sine and cosine are both positive. If you divide those, you will get a positive answer, or in the third quadrant, because in the third quadrant, sine and cosine are both negative, and when you divide two negatives, you will get a positive. So I know my answer is in one of those two quadrants, and as far as finding the answer, you really just kind of have to do a guess and check, and let's start at pi over 6. So I'm going to test x equals pi over 6, and I'm going to test that by doing sine divided by cosine. So that will be 1/2 divided by root 3 over 2. If you divide by a fraction, you flip and multiply, so that's 1/2 times 2 over root 3. The 2's will cancel, leave me with 1 over root 3. Let's see, is that what I wanted? No, I wanted root 3, not 1 over root 3. So that didn't work. Boo. So we have to try something else. Pi over 6 doesn't work. I know it's not pi over 4 because if you divide those, since those are the same coordinates, root 2 over 2 and root 2 over 2, you will get 1. So that means the answer is going to be pi over 3, but just to be sure, let's test it. If x equals pi over 3, my sine is root 3 over 2. And if I divide by cosine, I'm going to go ahead and skip this first step where I write the fraction sine over cosine. I'm going to go ahead and flip and multiply by 2 over 1. If you divide root 3 over 2 by 1/2, it's the same as multiplying by 2. The 2's cancel, leave me with only root 3, and that makes me happy. So that did work. So I know one of my answers is pi over 3. But that's the one in the first quadrant. Remember we said there are angles in the third quadrant that could be true also. Since I answered with the pi over 3, the one with 3 in the denominator was correct for the first quadrant. The one with 3 in the denominator, 4 pi over 3, will work in the fourth quadrant. If you don't believe me, you can divide the sine and cosine, and you will see that I am right because I'm a genius. Haha. So there's numbers 1 and 2. Solving trig equations, just have to be familiar with your unit circle. Number 3, same type question. 4 sine squared equals plus 1 is equal to 4. Just like number 1 and number 2, I'm going to isolate my trig function by moving everything else over. So first thing I will do is subtract the 1. And so that will give me 4 sine squared of x. 1 minus 1 is 0, 4 minus 1 is 3. Then I will divide by 4. I'll divide by 4. Those cancel, leaving me with sine squared x is equal to 3/4. Then I need to take the square root because it is sine squared. So I'm going to do the square root of 3/4, which would give me the square root of sine squared is sine. And the square root of 3/4 is the square root of 3, which I don't know, over the square root of 4, which I do know. And also remember, if you ever take the square root, that little green square root sign was my creation, so I have to do the plus or the minus. And let's clean this up one last little bitty bit. Sine x is plus or minus, square root of 3 does not clean up, but the square root of 4 is 2. So I need sine x to be plus or minus square root of 3 over 2. So to answer that, I will need to look at my unit circle, and sine is my y coordinates, and I need it to be positive and negative root 3 over 2. That means we're going to have a lot of answers to this problem. The first time around the circle, let's see, sine is positive root 3 over 2 right here and right here. So my answers of pi over 3 and 2 pi over 3. And negative root 3 over 2, my y coordinate is negative root 3 over 2 at 4 pi over 3 and 5 pi over 3. So we actually have 4 different answers for this problem. So there we are answering questions. And here for numbers 1, 2, and 3, we were solving the problems on the interval 0 to 2 pi. I gave you a specific interval on which to look when answering these, and you need to pay attention to the directions because the directions are about to change slightly. Here I only wanted my answers from 0 to 2 pi, but after I solve those, let's look at a different kind of question. And these are questions that say find all values of x. Find all values of x. I didn't say only from 0 to 2 pi. I said find them all. Find every single one of them. And in order to think about this one, make it a little bit clearer, I'm actually going to go into degree mode for just a minute. So I'm going to answer this question in degrees. Let's see, it's secant x minus 2 equals 0. I'm going to move the 2 over first. And I need secant of an angle to equal positive 2. We generally don't think very well in terms of secant. So I'm going to turn that. I know secant and cosine are reciprocals. So if secant x equals 2, that means that cosine of x is equal to 1/2. You simply take the reciprocal of the angle given. So we're going to pull in the unit circle here, and we're going to look at our unit circle and see if we can find angles where cosine is equal to 1/2. And just to make this a little bit easier to see what's going to happen, I'm actually going to answer in degrees. This is rare because I usually will answer in radians, but we're going to start off in degrees. I said find all values of x where cosine is equal to 1/2. So I know that one of those answers where cosine is 1/2, that happens right here at pi over 3 or 60 degrees. Yeah. Another answer would be down here at 300 degrees. So x equals 300. I'm going to move that down here. You'll see why in just a minute. So x equals 300 degrees. And those are two angles where cosine is equal to 1/2. But I think there are more. It says find all values of x that satisfy this equation. We only gave the answers between 0 and 360. There's no other coordinates on the unit circle from 0 to 360 that have those x coordinates. So there is, however, a way we can get more answers if we go around the circle more than once. So let's look at 60 degrees first for a second. If I have an angle of 60 degrees, let me go to my highlighter here. That means that I started at 0 and I went up around my circle to 60 degrees and I stopped. That's a 60-degree angle, and that's one of the answers I just got. But if I wanted to go crazy, I could actually go all the way around my circle a second time. So I'm starting at 60 degrees. If I go all the way around my circle a second time, I'm going to go all the way around, go past 360, and I'm going to come back to the place where I started. What I just did is I added 360 degrees to my starting point. I started at 60, and then I moved 360 degrees further, which means that I have another answer of 60 plus 360, and 60 plus 360 is 420 degrees. So x could be 60 or x could be 420. That's a second answer. And for the same reason, I could come down here to 300 degrees and I could add 360. So 300 plus 360 would be 660, yeah, right? So we're simply adding 360 degrees. And when I added 360 degrees, that gave me another possible answer. Oh, I stopped there. If I could go around the circle once, I could go around the circle another time. I could add 360 again. So 420 plus 360 would be 780 degrees. Same thing down here. I could add 360 degrees, and that would give me 1020 degrees. Well, if I could add 360 twice, I could add 360 again, right? I could keep adding 360 plus 360 plus 360 plus 360 plus 360 plus 360 plus 360, and I could come up with an infinite number of solutions. And I said find all of them. So it's going to be really cumbersome to write an infinite number of solutions. So what we do for problems like this is we shorten it just a little. Just a little. We shorten it a whole lot. What I will do is I will synopsisize. I like making up words. I will take all of this and I'm going to rewrite it as I'm going to start at 60 degrees. That's one answer. But then I'm going to add 360 degrees. And, I can add it once. I can add it twice. So multiply by 2. I could add it 3 times. So plus 360 times 3. I could add 14 360s. So 360 times 14. I can multiply by any number. So what we do is we'll say 60 degrees plus 360 times some unknown number, k. So our answer is going to be 60 degrees plus 360 k. And I would do the same thing for this one. I would rewrite this as x starts at 300 degrees, and then I can add 360 degrees times some number k. K could be 1, k could be 4, and these are our solutions when I say find all solutions for x. Now those are the degree answers. I generally answer in radians, so if I wanted to do this in radians, let me move this down a little bit. If I wanted to answer this in radians, then it's the same concept except we just use the radian angle measures instead of the degrees. So in radians, we would say x is equal to 60 degrees, which is pi over 3 radians, plus, and the whole circle in radians is 2 pi, so we'll say times 2 pi k, and that would be your radian answer. Same thing down here. In radians, x would be 5 pi over 3, which is the same thing as 300, plus 360 degrees is the same as 2 pi radians times k, and that would be your answer in radians. I prefer radians, so from this point forward, I'm going to answer in radians, but there you go. So if you want all values of x, you simply find your first two answers like you normally would, and then you add 2 pi times k. Let's try this one. And I'm going to move into another type of solution here. This one we're actually going to have to factor to solve. And I know that's kind of weird because now I'm combining two things that you love, that being trig functions and factoring. And I hope you don't like pee in your pants with excitement over this problem. One thing I notice here is I have sines and cosines. I would try to get them in terms of like have only one trig function. But in this case, I cannot get just one trig function. So what I'm going to do is I'm going to move my cosine x over to the other side of the equation. And that would give me cosine x times sine x. And you can't combine those. So it's going to be cosine x sine x minus 3 cosine x. On the right side of the equation, that equals 0. And then what we would do is we would factor out the cosine x. This problem is looking kind of weird, though, so hang on just a second. Let me make sure I copied this down right. Yeah, okay, this is fine. Anyway, so I'm looking at this, and now I see that I have a cosine x in common. I have a cosine x here, a cosine x here, so we can actually factor out a cosine x, and when I factor out that cosine x, I'm going to be left with, see I had cosine times sine, all I have left is a sine x, minus, then I had 3 cosine, but I pulled the cosine out, so now I only have a 3, equals 0. And if you remember when you solve by factoring, once you're through factoring, I pulled out the cosine x, you set each factor equal to 0. So I have 1 out here, I have cosine x. I'm going to set that equal to 0, and I'll solve that equation. And then I have sine x minus 3. I'll set that equal to 0 and solve that one. Now again, we are finding every answer, so this is where we do the plus 2 pi k thing. I'll look at my unit circle, and my unit circle, cosine x is 0. That's your x coordinate on the unit circle. That happens at pi over 2 and 3 pi over 2. So x is, for this answer, when cosine is 0, that happens at pi over 2 and 3 pi over 2. But I did specify to find all solutions, so that means we add 2 pi k to each one. So there's 2 answers. Then I'll look over here at the sine equation. I need sine x minus 3 to equal 0. So sine x, I'll start by moving that 3 over. Sine x equals 3, and that means I need to look on my unit circle and find the place where my y coordinate is 3. And we run into a problem, because if you look at your y coordinates, the largest y coordinate, the furthest up the y-axis I get is a y coordinate of 1. I'm trying to find the place on my unit circle where my y coordinate is 3, and 3 is going to be way up here somewhere. My unit circle never makes it to 3. So this problem, sine x equals 3, there's actually no solution for that part. And so our only solutions to this whole equation are pi over 2 plus 2 pi k and 3 pi over 2 plus 2 pi k. And so that's one where you factor, get everything on the same side of the equation, pull out what they have in common, and then set each factor equal to 0. Okay, this one, it's a kind of the same situation. I've got 2 cosine squared and a sine in here. I have 2 different trig functions, and if possible, I like to change one into the other. On number 5, that wasn't an option. There's no way I can turn just a cosine into a sine or a sine into a cosine. But this one's a little bit different because I have a cosine squared. And if you remember the main trig identity, if you only have room in your brain for one, the one you need to know is this one, sine squared plus cosine squared equals 1. And if sine squared plus cosine squared equals 1, then you can take the sine squared and move it to the other side of the equation to get cosine squared equals 1 minus sine squared. So I would take 1 minus sine squared, and I'm going to plug it in for cosine squared right here. And the reason I want to do that is because that now gives me only one trig function. The only trig function I have in this equation is sine x. And now we need to try to solve this equation. Uh, let's see, first thing I'm going to do, I'm going to distribute the 2 through these parentheses. 2 times 1 minus 2 times sine squared x minus a sine of x minus a 1 is equal to 0. Um, let's see, on the left side of the equation, I can do 2 minus 1. 2 minus 1, and last time I checked, that was 1, so I have 1 minus 2 sine squared x minus sine x is equal to 0. And this problem is getting a little bit hairy because I have this pesky sine squared and sine. Those do not combine. Notice I didn't try to throw those together into one sine cubed or something like that. You can't combine that. So what I'm going to do is a trick that we actually did earlier this year. What I see in this problem, and hopefully y'all can see this too, I see 1 minus 2 times something squared minus that same something. So in my mind, I'm seeing 1 minus 2 times something squared minus that same something equals 0. That's what I see. So what I'm going to do is I'm going to do a little tricky substitution here. And I'm just going to say, for just a minute, let's take out the sine x and let's plug in a. Because if I do that, then I get 1 minus, instead of sine squared, that's going to be a squared, or 2a squared. Instead of sine x, that's going to be just an a equals 0. And now I need to try to solve that equation by factoring. 21 minutes. I need to hurry up and finish this. This is the last problem. All right. If you ever have a squared, you want it to equal 0, which this one does. But I don't like the negative 2a squared. I would rather have a positive a squared. So what I'm actually going to do is move every single thing to the other side of the equation. So I'm going to move the negative. I'm going to move the 1 over, the 2a squared, and the a. And over here, everything's going to cancel. 1 minus 1, negative 2 plus 2 cancels, negative a plus a cancels. And I get 0 is equal to negative 1 plus 2a squared plus a. And then I'll rearrange it because I like my squared term to be first. 2a squared plus a minus 1. And now we try to factor 2a squared plus a minus 1. All right, so looking at this, I have 2a squared plus a minus 1. That factors 2. Let's see, it's going to be something times something. I know that 2a times a would give me 2a squared. I know that 1 times 1 will give me a 1. And I need a positive a, so I'll be what, minus 1 and plus 1. That's just old-fashioned factoring, like we did in 9th grade and 10th grade, or 10th and 11th, whatever. Then once you factor, you set each factor equal to 0. So 2a minus 1 equals 0. That means a is going to equal 1/2. I have a plus 1 equals 0. That means a equals negative 1. But remember, we're trying to solve for sine x. We're trying to solve for x, not a. So once I get this part done, I then go back and I'll plug my sine x back in for a. So I need sine of x to equal 1/2, and I need sine of x to equal negative 1. And I'm going to spare you the unit circle. The answers to this, if x is equal to 1/2, if sine is equal to 1/2, your y-coordinate is 1/2 at pi over 6, and again at 5 pi over 6. And over here, your x, or if sine x is equal to negative 1, the y-coordinate on your unit circle is negative 1 at 3 pi over 2. And again, number 6, the original equations were find all solutions. So I'll simply add 2 pi k to each of these. And this one ended up being a lot trickier than I thought it would be. So there are our solutions for this equation. And that's finally it. 24 minutes. Holy cow. I'll give you a warning, so maybe you can break this up. I don't know. Should I just talk till 25 minutes? Have you ever had a 25-minute video in here before? I'm not sure. That's good enough.